every single night, if you look up, the moon seems to be changing its shape. But what if I told you it doesn't actually change at all? The phases of the moon, they're really just this beautiful illusion. And it's all about one simple thing, your perspective. I mean, it's probably the first question so many of us ask when we start looking at the night sky, right? One night it's this brilliant full circle, and then just a few nights later, it's a tiny little sliver. So what is going on? Why does the moon appear to change its shape so dramatically? Okay, before we really dive in, we have to clear up the single biggest misconception out there. A lot of people think the phases are caused by the Earth's shadow covering the moon. Nope, that's actually a lunar eclipse, which is a totally different thing and way rarer. The real reason is, well, it's actually much cooler. The phases are just our changing view of the moon's sunny side as it circles around us. So let's get into section 1, a trick of the light. We're going to cover the two simple principles behind the phases. And trust me, once you get these two things, everything else about the lunar cycle just clicks into place. All right, principle number 1 is all about reflection. And this is absolutely key. The moon is not a light bulb. It doesn't make any of its own light. It's basically a giant dusty mirror hanging out in space. The only reason we can see it at all is because it's reflecting sunlight. So you gotta remember, at any given moment, half of the moon is lit up by the sun, that's its day side, and the other half is in total darkness. Okay, and principle number 2 is orbit. The moon is always on the move. It's constantly doing this big, predictable loop around our planet. And it's this amazing cosmic dance between the sun, the earth, and the moon that creates the incredible show of phases we get to see from down here. And here's a fantastic way to picture this. Seriously, you can even try this at home. Imagine you're in a dark room with just one lamp on. That lamp is the sun. Your head? That's the earth. Now, hold a ball out at arm's length. That ball is the moon. As you slowly turn around in a circle, keep looking at the ball. You'll see the light from the lamp hit it in different ways, right? It creates little phases on the ball, and that's exactly what's happening up in space. Moving on to section 2, the moon's 30-day orbit and the rhythm of the lunar cycle. So this orbital dance we've been talking about, it's not random at all. It follows this super precise rhythm. It's like a giant celestial clock that people have been using for thousands of years. So what's the timing on this clock? It's 29.5 days. That's the magic number. That's how long it takes for the moon to go through its entire playbook of phases, all the way from a new moon where it's totally dark to a big, bright full moon, and all the way back to dark again. Okay, section 3, a tour of the phases. Let's go from new moon to full moon and right back again. We're going to walk through all 8 of the phases, starting with the one where we can't see the moon at all. So the whole cycle kicks off with the new moon. Now, at this point, the moon is sitting right between the Earth and the sun. So think about it. The sun is lighting up the side of the moon that's facing away from us. The side facing us, it's getting no light at all. So from our point of view, it's completely dark. It's basically invisible up there. Okay, quick guide to moon watching. Before we go any further, there are 2 words you're going to hear a lot: waxing and waning. Waxing just means the bright part is getting bigger. Think wax on. And waning means the bright part is shrinking. And here's a really cool trick if you're in the northern hemisphere. If the light is on the right side of the moon, it's waxing. If the light's on the left, it's waning. Simple as that. All right, let's follow the light as it grows. These are the waxing phases. So right after the new moon, we start to see this beautiful, tiny sliver of light. That's your waxing crescent. Then, about a week later, we get to the first quarter. Now, I know, it looks like a half moon, right? But it's called a quarter because the moon has gone 1/4 of the way around its orbit. After that, the lit up part keeps growing bigger, and we call that a waxing gibbous. And that brings us to the peak, the main event, the full moon. This is when the Earth is smack dab in between the sun and the moon. So now, the entire side of the moon that faces us is totally lit up by the sun. It's glorious. It rises right around sunset, and it just owns the night sky. Okay, so after the big show of the full moon, the process just flips in reverse. The light starts to disappear, we get the waning gibbous phase first, then we hit the last quarter, where the other half of the moon is lit up, and finally, you get that last beautiful shrinking sliver, the waning crescent, before, poof, the moon vanishes into the new moon, and the whole amazing cycle gets ready to start all over again. All right, section 4 is all about phases versus eclipses, because there's a tiny tilt that changes everything. Now, you might be thinking, hold on a second. If the moon is between the sun and Earth every new moon, and the Earth is between the sun and moon every full moon, that sounds like a perfect lineup, right? Which leads to a really good question. Yeah, why don't we get a solar eclipse every single month at the new moon? And why isn't every full moon a lunar eclipse? I mean, the alignment seems perfect. Why are eclipses so incredibly rare? Well, the whole answer boils down to one tiny but super important number: 5.1 degrees. So here's the secret. The moon's orbit isn't perfectly flat like a racetrack. It's actually tilted by just over 5 degrees compared to the Earth's orbit around the sun. And because of that tiny little tilt, most of the time the moon passes just a little bit above or a little bit below the Earth's shadow. Eclipses, they only happen on those super rare occasions when everything lines up perfectly on that flat plane. Okay, let's wrap up with section 5, the moon's earthly influence. Because this whole celestial dance, it's not just a pretty show in the sky. The moon's orbit has some very real and actually very powerful effects right here on our planet. And maybe the most dramatic influence of all is the one it has on our oceans. I love this quote. The rhythmic rise and fall of the ocean is one of nature's most reliable phenomena. And you know who we have to thank for that? Yep, the moon. This is all about tidal forces. The moon's gravity is actually strong enough to pull on Earth's oceans. It literally creates a bulge of water on the side of the Earth closest to it, and another bulge on the far side. And as our planet spins around every day, we're just rotating right through those bulges. And that's it. That's the constant rise and fall of the tides. And you know what? This same orbit also answers another question people always have. Why can I sometimes see the moon during the day? Well, the truth is, the moon spends just as much time in our daytime sky as it does in the night sky. The only catch is whether it's bright enough and in the right spot for us to see it against the bright blue of our atmosphere. So the next time you look up at the moon, remember what you're really seeing. It's not the moon that's changing, it's your point of view. You're watching a cosmic dance so powerful, it literally moves our oceans, and so ancient that it was our very first calendar. It really makes you wonder, doesn't it? What else in our lives is being quietly shaped by this constant, steady celestial rhythm?